So now we're going to be working with two-step equations, and we're going to do them both pictorially and symbolically. So we have an example here, 2a plus 6 is equal to 12. Once again, yellow is positive in our textbook and red is negative, so I'm just going to stay consistent with that. So we have two variable tiles and 6 units on the left-hand side of our equation, and we have 12 unit tiles on the right-hand side. Once again, the whole idea is to get one of these variable tiles by itself on either side of our equation. So the way that we do that is, let's get rid of our 6 unit tiles. So we zero out our 6 yellow with 6 red. Whatever I do to one side, I must do to the other. So really, I'm adding 6 negatives or subtracting 6 from both sides. So we zero these ones out, and we can zero these ones out. And you'll see that we now have 2a's is equal to 6. So again, if we know that 2 variable tiles are equal to 6, we want to find out what 1 is, and so we group them into 2 groups. So if 2 is equal to 6, we divide by 2. One of our variable tiles will equal to 3. So our solution is a is equal to 3. Well, let's take a look now at the exact same equation, building it with an arrow diagram. So once again, in an arrow diagram, we start with our variable. We do the order of operations, so we times by 2 first to build the equation, and then we added 6. So we get 2a plus 6 on the left-hand side of our equation. Once we have the entire left-hand side, we now put it equal to 12, and we start on the right-hand side and we undo everything. So here we added 6, so from 12 we subtract 6 to get to 6. Here we multiplied by 2, so now we divide by 2 to get to 3, and that should be our answer. So now when we try without models, so means symbolically, if I start with 3p minus 4, it does mean the same as some number multiplied by 3 minus 4 or subtract 4 is 5. That's what it means in words. So again, I want to get the variable by itself, so I have to get rid of these 4 red tiles. Minus 4, and the way I do that is plusing 4. Whatever I do to one side, I do to the other. So these 2 here zero out, and we simplify the right-hand side to give us 9. So we get 3p, those are gone now, that's 0. So we get 3p is equal to 9, and now we divide by 3, and we get p is equal to 3, because that will now cancel. So let's just do one together. We're going to work through this and we're going to verify because this is a little bit different. So 2a plus 7 is equal to 12. So again, we have to get a by itself, so we get 0 out that plus 7, and we get 2a is equal to 5, and then we divide by 2. I'm just going to change it to a decimal. You can leave it as a fraction. I'm going to change it to a decimal because it's easier when we verify. I really wish I had my pen. And we have right-hand side. So on the left-hand side of our equation, 2a plus 7. And on the right-hand side of our equation, we have 12. So again, when we verify, we take the variable out and we put our solution in, because we say that that number, a, is equal to 2.5. So 2.5 times 2 is 5, and 5 plus 7 is 12. The left-hand side equals the right-hand side. We know we did the equation correct, or the solution correct. So I want you to stop here. I want you to stop and try these ones. Okay, and welcome back. So here we have some number divided by 3 plus 8 is equal to negative 15. Again, we need to zero out that plus 8. We do that by subtracting 8. That's equal to negative 23, I believe. This is some number divided by 3, so we're going to times by 3. So those two cancel, and I get negative 69. I'm going to leave that one, and I'll verify the other one for you, just in case. I'll make sure I have enough room though. If you remember, if you've been following my videos, I always say that if the negative is in the middle of our fraction, we always put it to the numerator. You can put it to the denominator, but it's just a little bit more hassle. I'm going to zero this out already. I'm going to zero out the plus 6 or the minus 6 with a plus 6. So I have negative x over 4 is equal to negative 1. I have a divide by 4 here, but I'm actually going to multiply by negative 4 because I have to get rid of this negative as well. And in order to get rid of a negative, to make it positive, if I times by a negative number, those two now become positive x. And that goes as well. Whatever I do to one side, I must do to the other. And I get positive 4. I'm going to verify this one just to show. I'm not going to verify all of them, but I'll verify the ones, when I see something that looks a little different. I wonder if it'll stop the clicking. No, I guess not. That's worse on my mouse or on my pad here. Okay, so I get negative x over 4 minus 6 on the left-hand side of my original equation. I have negative 7 on the right-hand side. Now when I substitute this positive 4 in here, this negative changes it to negative. Okay. So now I have negative 1 minus 6, and I get negative 7. Negative 7 is equal to negative 7. I know I've done it correctly. Okay, what else do I have in store for us here? Oh, let's change some words into equations and solve it. So again, turning these into an equation, a number divided by 2 plus 8 is negative 16. I'm going to call my number a this time. I'm going to divide by 2. I'm going to add 8. And is always meets equals is negative 16. So once again, I'm going to zero that out. And then I have some number divided by 2, so I'm going to multiply that by 2. Whatever I do to one side, I must do to the other. And now I get negative 48. I'm not going to verify this one because I just verified the other one. Why don't you guys give this one a try? Pause the video and then come back when you have a solution. Welcome back. So in this example, we want to write the equation and solve. 15 more than negative 3 times a number is 21. Okay, so let's call the number, let's go x this time. So it says 15 more than negative 3 times a number is equal to 21. Now the reason why I put the brackets around the negative 3 is because if I put plus minus, that doesn't look quite right. Now remember, an equivalent expression is representative of, it doesn't matter what order the terms come in as long as they stay the same color. So this term right here is actually 3 red variable tiles. So it doesn't matter if they come first or second, this still remains 3 red variable tiles. This is 15 yellow tiles, unit tiles. So I'm just going to reverse the order just so it looks a little bit cleaner. You can still do it like this. I just don't like these two signs together. That's all. Once it looks like this, it looks a little cleaner. You can see it pretty clearly. I zero out that positive 15 with a negative 15. And I have negative 3x is equal to 6. And divide by negative 3. I'm pretty sure I can skip that step now where I'm dividing both sides by negative 3 to give me negative 2. Okay. Okay, so here are some different examples of solving equations. Equations with rational numbers and fractions or decimal form cannot be modeled very easily, but we can still solve these equations using inverse operations, even if the variable is in the denominator. So now, when the variable is in the denominator, the variable will not be cannot equal to 0. The denominator can never be equal to 0. So when that variable, like in here, I have 4.2 is over x is equal to 3, x cannot equal to 0. That is a stipulation. As soon as that denominator is equal to 0, that sends that equation right to infinity, and that's not calculable. It does not exist. There is no solution. Okay? You'll learn more about that in high school. All you guys have to know is that the variable, the denominators cannot equal to 0. Okay, in this example, I really don't like teaching cross multiplication, but in this example, and for grade 9 students, I think it's perfect. So here I'm going to cross multiply. So the numerator of the first fraction times the denominator of the other fraction will always equal to the numerator times the denominator. So thus the cross multiplication, that will always hold true. So now I have 4.2 is equal to 3x. We're going to divide by 3. And we are going to get 1.4 is equal to x. We do always have to check to make sure that our solution doesn't conflict with our restriction of that denominator. And in this case it doesn't, so therefore it's a solution. Okay. So once again here, I have 2 divided by x is equal to 0.5. I'm going to put that 0.5 over 1. Sorry, I have to say this. X cannot equal to 0. That's a stipulation because the x is in the bottom of the fraction, which is called the denominator. So in this case, once again, I don't like teaching cross multiplication, but in here, I think it's a good strategy. Oops, that's x. Okay, so I have 2 is equal to 0.5x. I'm going to divide by 0.5x, or sorry, 0.5, not the x. And those two cancel, and that gives you 4. I have to make sure that I look at my restriction. They're not the same thing, so therefore that is a solution. We're going to revisit this in lesson 2, so if you don't quite get it yet, I'm going to look at it again in unit 2. Here are some, I'm going to stop here and I'm going to create a third video for this lesson for the step 3 types of equations.